Okay, hello, this video is about oxidation numbers. We're going to look at what oxidation numbers are and what the rules are for oxidation numbers and how we can assign them to atoms in a compound. So oxidation numbers basically help us follow and track the movement of electrons. So in some ways they are a little bit fabricated. They're different to charges of ions, although they do overlap. But they give us a way of assigning a number, and from there we can work out whether something in a reaction has gained or lost electrons. So a basic definition is the total number of electrons that an atom gains or loses in order to form a chemical bond with another atom. But as you'll see, it does oversimplify things. It looks at all compounds, looks at them as if they're all ionic, but we know they're not. Carbon dioxide, for example, is covalent. But for the purposes of oxidation numbers, we kind of make an assumption that it's behaving ionically. We'll see more as we go on. So, with oxidation numbers, there are rules that you have to follow in order to make them work. The first rule is that all elements have an oxidation number of 0 because they're not bonded to anything. So, if you take calcium just by itself, its oxidation number will be 0. If you take fluorine, which is diatomic, its oxidation number is 0. Oxygen, 0. You get the idea. So it doesn't matter if it's a metal, a non-metal like sulfur, or if it goes around in molecules like sulfur does, its oxidation number will be 0. Okay. So what we're really interested in though is what the oxidation numbers are when they're in compounds. There's a few that you have to remember. One of the important ones, fluorine, is the most electronegative element on the periodic table. Okay, its oxidation number in a compound is always -1. There's no exceptions to that. Oxygen is very electronegative as well. It does have some exceptions, but normally its oxidation number is -2. It normally gains 2 electrons when it bonds to things. Hydrogen is normally always +1. Hydrogen normally loses an electron when it bonds. So there are exceptions to these two, which we'll see, but they normally, the exceptions are rare, these normally hold true. This one always holds true. But remember, this is in a compound. Fluorine, as in F2, would be 0. All these are in a compound. If you take something from group 1, like sodium, potassium, okay, they will be +1. So for example, in NaCl, the sodium has an oxidation number of +1. If you take group 2, you have something like calcium, magnesium, they'll be +2. So magnesium chloride, the magnesium has an oxidation number of +2. Its charge is also +2, but in this case the oxidation number is +2. And then also, if we look at the halogens, or the halides I should say, group 7, Cl-, Br-, I-, their oxidation numbers are normally -1. So the same as fluorine, but they're not as electronegative as fluorine, so there will be some cases where they won't be -1. So you go back to that same chloride, the oxidation number we said sodium was +1, the oxidation number of chlorine is -1. Okay, so I mentioned that there are some special cases where these rules don't follow. Basically, if you learn these rules, you won't go too long, but there are some special cases. So, hydrogen is +1, except in metal hydrides. Now, metal hydrides we don't see very often, but a metal hydride would be a metal with hydrogen. In this case, the hydrogen oxidation number is -1. So another example will be here. Oxidation number of hydrogen is still -1. There's 2 of them, but each one is -1. Oxygen in peroxides. So peroxides, most common one will be hydrogen peroxide. The oxygen is actually -1, not +1. Sorry, not -2. So here we'd have the hydrogen, so you have 2 lots of +1. We have the oxygen, 2 of them, so we have 2 lots of -1. So this is an exception. Oxygen is nearly always -2, apart from in peroxides. And also when it's bonded to fluorine. In this case, the oxidation number would be +2. So an example would be F2O. The oxygen here is +2 and each fluorine is -1. So there are 3 exceptions. Okay. We will also see that from the rules here that these ones down the bottom are not always -1. Quite often they are, but it depends what they're bonded with. Especially when you start bonding things to oxygen, it's unlikely that the oxygen is going to be -2 and the chlorine is going to be -1. These oxidation numbers can change a lot. But group 2 are always +2. Group 1 in a compound and group 2 in a compound. So group 1 in a compound always +1, group 2 in a compound always +2. One exception for hydrogen where it's not +1. Peroxides and bonding to fluorine, it's not -2, but otherwise always -2. Okay, so down here, these ones here are pretty much always what we say they are. These ones can vary depending on what they're bonding to. Okay, so if we have a look at what we do in a compound then. So we saw that if they're elements, they're 0. But what about if they're compounds? Well, if they're compounds, the sum of the oxidation numbers has to equal the total charge. So let's have a look at an example of that. Let's take CO2. The total charge of this is 0. So say TC, total charge equals 0. So the oxidation numbers have to add up to 0. I've got 1 carbon here, and I've got 2 oxygens. So whatever the carbon is, plus the 2 oxygens has to equal 0. Well, we didn't learn any rules for what carbon is, and that's because its oxidation number changes quite a lot depending on what it's bonded to. But we did see that oxygen is nearly always -2. So, notice here I'm saying oxygen's oxidation number is -2, not -4 because there's 2 of them. That'll come to a total -4. But each oxidation number is what each atom is individually. It's -2. So something plus a total of -4 equals 0. That means the carbon has to be +4 in this case. You see the sign's important. Let's have a look at another one. NH3. So we've got a nitrogen plus 3 lots of what hydrogen is has to equal 0 again. There's no charge on ammonia. So we saw that hydrogen is nearly always +1. So that gives you a total of +3 has to equal 0. So nitrogen would have to be -3. Okay. Let's look at one now where there is a charge. So if I do then nitrate ion. Okay. Now here the total charge this time is -1. So got 1 oxidation number for nitrogen plus 3 lots of oxidation numbers for the oxygen has to equal -1 this time, not 0. So oxygen is -2. So 3 times -2 gives us -6. We don't want to get to 0 this time, we want to get to -1. So something -6 equals -1 has to be +5. So the oxidation number of nitrogen there is +5. So what we basically do is use those rules and we work out the unknown.